Welcome. Thank you for joining us. My name is Mateo Cardona and I am the VRV Product Manager. For more than 35 years at Daikin, we have invested, innovated, and introduced new air conditioning system technologies all over the world, always with the aim of maximizing the consumer and our installers' experience. During this presentation, we are proud to introduce to you the Headerpack and the DGT. Continuing with our tradition, we are confident that this new product will break the paradigms of how VRV systems are installed today. Simplicity, efficiency, profitability, and security are the fundamental elements that were considered in the development of these new accessories. Together, with the help of this new innovation, we expect to change the way the market installs equipment today. Now it is my pleasure to introduce to you Andres Zamora.
Thank you for being with us today. This is a special day where we're going to be launching our Headerpack and our DGT. Before we go into the matter, I want to introduce myself. My name is Andres Zamora, and I've been here with Daikin for over 10 years now. So before we go enter into what we want to launch, I want to talk about what's important or the three main pillars of a VRV system, right? So we have the design, then we have the installation, and then we have the service, right? So Daikin is very focused on these three pillars, and we are dedicating a lot of time on developing the knowledge of our DNA as far as to know how to design a VRV system. And we also focus on the consultants engineers, and we bring all the information, all the tools, all the references, so they can do a good design. You know, sometimes when we do designs based on a rule of thumb, we end up designing or oversizing the equipment or undersizing the equipment. So that's why it's very important to have the right design, right? As far as the installation, we concentrate in developing our DNA, right? We bring in the right technology. We want them to have the right experience on installing VRV systems. This is not just a DX equipment. We want them to know what they're doing, right? So that's one of our main commercial strengths. And as far as service, we want you to have all the resources, all the parts, all the tools available for you to do your job, right? So I created these analogies, this three-legged table analysis that I call one of the legs, the design. The second leg is gonna be the installation, and the third leg is gonna be the service. So what happens if one of the legs breaks, right? The system is gonna come down, right? So that's why these three pillars are very, very important to the design of a system, right? So I got this statistic table that shows me, I'm gonna move here to my computer, that shows me that between the first year, the main cause of compressor failure is because of mainly poor installation, okay? That's what this table is showing me. After the 2 years to the 8th year is mainly because of accidental. This could be a hurricane, it could be an earthquake, or it could be probably the lack of the service in there too. And after the 8th year, it's just the worn out failure, the life cycle of the equipment that is wearing down, right? So our main focus is here. We want to lower this peak, right? And we want to avoid those installation problems, okay? So what is important to our customer? Our customers wants to be able to do an installation, a clean installation, avoid any accident, right? Not having a site like you can see on the first picture on the left where it looks a little messy, right? They want to protect their own people, right? And they want to protect the end user as well, not causing any fire. Sometimes also the shortage of the talent as far as doing the welding is very difficult in some markets, and they tend to be also more expensive. So the dependency on these guys makes the jobs a little harder. And customers also want to be able to finish the job on time, right? So they want to, keep the word. So that's also important to the customer. So what Daikin is doing about this, we have developed a workshop in Chile, right? That we call in PPM, and that's pre-piping manufacture, right? Where we go on site, we measure the site, we see where the piping is gonna go, then we take it to this lab and we do all the welding, all the bracing, we do all the testing, we put all the insulation, and then we take it to the field. But what's the problem with this? That this is only available in Chile, right? And as you guys know, Chile is way down there in our continent, right? So the logistics to move this piping from there it makes it very, very hard and almost impossible. So what we can do, what we can do to better the installation and make it faster and easier. So we decided to launch the header pack, right, and the DGTs. And basically what this is that we have two headers in here, right, that are gonna be connected to the condenser on this side, right, and this connection on this side is gonna be with the DGTs. No fire involved, no welding on this side. And on this side, we're gonna connect the exit of the header pack. We're gonna connect to a flare. This is a flare connection, okay? And the flare connection is gonna connect to a flexible piping, right? So it's gonna be a lot easier to move and manipulate those copper piping, right? So you're saving 1/3 of installation time with these guys. You have an easy installation, no welding at all. You're not using any welding, 0 rigs or bringing fire into the place. The equipment is low profile, as you can see, 14 centimeters, and we have all the information available for you. You can connect 4 or 6 indoor units to this header pack. Okay, I'm gonna sound a little repetitive, but I want this information to sink in with you guys. And if you got any questions, just let me know. I'm gonna leave my email at the end so we get the other questions. So we have the DGTs, right? And I'm gonna go more in detail about that. And we got the header packs. Connection to the condenser on this side with the DGTs, and on this side we're gonna connect to the flares, and it's gonna go to each indoor unit with flexible piping, L-type. Okay, L-type. We're going to connect 4 to 6 indoor units to this guy. So basically here what I'm showing you is a connection of 5 ref necks. As you can see, 1, 2, 3, 4, and 5. Each one is going to have 3 bracing, 1 in liquid and 3 more in the gas side, right? So we got 15 bracing here, another 15 going back. So that's 30 bracing points. So you need a special guy to do this type of installation. You cannot hire just a guy that just install mini splits to do this. No, you need to hire a special guy, special talent that knows what he's doing to do welding with nitrogen. With the header pack, we are avoiding this. You don't need to hire that guy anymore, because all you do is on this side, you use the DGTs, and on this side is gonna be a flare connection that is gonna go to each indoor unit. As you can see here, the exit, my DGTs, and here is the flexible L-type copper, right? So before you needed at least 50 centimeters to do an installation with fire. Now you don't need, you only need 20 centimeters to do an installation, okay? So it makes it a lot easier. Now this is how 5 ref necks look. That is gonna be connected to 6 indoor units. The recommendation between ref necks is 1 meter. So we got up to 4 meters here. All of that is condensed into this header pack, right? Making it a lot easier to do the installation, a lot faster to do the installation. We keep the same piping limits from the condenser to the last indoor unit. It's gonna be 165 meters, and from the header pack is gonna be 40 meters to the last indoor unit. Here on the bottom, I'm gonna give you some examples. You can have many header packs, because my limitation is not going to be the header pack. My limitation is going to be 64 indoor units, which is D3 net, the architectural Daikin, right? So now you can combine header packs with ref nets, but what you cannot do is to have a ref net after a header pack, okay? So it keeps the same rules as VRV4, okay? Now here's another example. You can have the condenser outside and bring the main pipe, right, connected with the DGTs going to the header pack, and from the header pack, flare connection, remember, to each of the indoor units, right? This is flexible connection. And you know, sometimes we are the last trade to go into the building, and usually we're gonna find a lot of obstacles on the building. So this flexible piping makes it a lot easier for you to do the installation. Now on the right hand side, we're gonna see the combination of header pack with ref nets, right? Ref net goes to an indoor unit and then comes down and goes to the other indoor units on the bottom, and you have a ref net here. Or you can just simply add another ref net here, right? Add your DGTs and then go to each indoor unit. as you can see, right? Now, this next table is gonna show you the model numbers of the header packs. And you can see they have a number in the middle from 6 to 16. These are horsepower, right? So the units, let's pick one for example. The 10 horsepower is gonna have a outside dimension connected to a DGT. It's gonna have 6 ports. From those 6 ports, 3 are large, 3 are small. The 3 large is 9.5 diameter and 15.9, and the other ones are 6.4 and 12.7, right? And the units that you see highlighted with yellow are the ones that we're gonna keep in stock, okay? So the VRV Express is gonna allow you to select these units based on the capacity index, their size on the capacity index, and you're gonna get a cover for each space, so you don't need to use each space, okay? So you just keep the top right there, so if you're not gonna use it, and we're gonna have all of those models in stock, all right? So it's gonna make your installation a lot faster. Now let's go into the DGTs, right? This is a non-brace connection, and the name DGT stands for Gas Tight Join. It's easier to call it DGT. So the DGT, as you can see here in this picture, there is a lot of engineering inside these DGTs, right? But the main points are the point A and point B, which this is a protection that is gonna go into the surface of the piping. It's not gonna break it, but it's just gonna hold it. It's gonna lock the piping in there, okay? So how's the installation of these DGTs? It's very simple. It's a 3 steps. You're gonna, once you get the DGT, it's gonna come with a rule that you see there, the blue rule, and the rule has some diameters on it. Based on the diameter of this piping, you're gonna make the line, right there, like an L shape. Then you're gonna get the DGT and insert it to the line, as you can see there, tied it by hand first, and then use 2 adjustable wrenches, or monkey wrenches, or American wrenches, they got different names, and just tie it until this green line disappears. Okay, it's that simple, that easy, okay? Now, with the same rule, let me go back here, with that same rule right there, you see these 2 little arrows right here? Those 2 little arrows, we're gonna use them to confirm that we did a good installation. If the line that we did with the marker is inside these 2 arrows, that's a good installation. If the marker is after those 2 arrows, that's not a good installation. And over here, if you don't see the black line, it's because you haven't tied it enough, right? So these units can handle a pressure of 17.7 17.2 megapascals. That's the pressure that they can handle. That's 4 times more than the pressure required for R410, which is 4.3. All right, so they're safe to use. You don't use any welding. You don't use no fire, right? You don't use nitrogen to do this installation, so it reduces the installation time cost. It's a lot safer for your people and for your customer. Okay. Here we can see the models that we have, and remember, you don't need to worry about this because the software is going to select it for you. We have the connections for the same size piping and connection for different type of piping, okay, different diameters. Now, the recommendation about the piping is that it has to be copper pipe according to the ASTM B280 standard, okay? That's the standard you got to use, and follow the thickness of the ASTM B80L type. And over here you can see the tolerance. We're gonna share this information with you guys, so you guys make sure to have this type of piping, okay? Now I'm gonna show you a video that is gonna show you how easy is the installation, and I want you to look at the time for this. Now this is an apartment application where you're gonna see a VRVS single phase, right, installation. But this is not limited to VRVS. It's also, you can also do VRV4 3-phase, so you can go up to 50 tons. Remember, my limitation is gonna be 64 indoor units. not how many header packs we can have. So we start at 8 o'clock, right? We connect to the condenser, DGTs, and then go into my header pack. So no welding, no bracing. There you go. Half an hour. From there, I'm gonna go with flare connection to my indoor units. So 2 hours and a half, you can finish 4 to 6 indoor units. Okay, it's gonna look a little repetitive, but it's gonna show you how to do the installation. You do the marking, you insert the DGT, you tight it until the green light disappears, and do the same procedure to all of them until the green light disappears. It's going to show you how it works. So does protection go into the piping, but it doesn't penetrate the piping. Then flare connection, so the importance of having the right tools to do this flare is very important. Now it's going to show a VRV 3-phase, ones that can go up to 50 tons. And you're going to see the combination of ref nets with header packs. So we got several header packs. And it's coming from the condenser on a main pipe and going down to each header pack. It's very easy and fast to do an installation. All right, now let's look at another video that is going to show us how to install the DGT. Okay, and this will be quick. It's going to repeat a little bit at the beginning, but then it goes into the installation of the DGTs. Right, so again, using the right tools to do the right cuttings right there of the piping. Make sure you clean that pipe, all that residual after cutting. Make sure you clean it and do the chamfering inside and outside. Okay, clean the excess residuals. Alright, that's soft copper, L-shape. Do your markings depending on the diameter of the piping. Now insert the DGT. All the way in till it covers the marking. Try to be as horizontal as possible so you don't blend the piping. First tighten it by hand and then use the tools. Again, no knee or any special tool, just an adjustable wrenches is fine. And make sure the green line disappears. If you can see the green line, that's not good application. So it has to be all the way close. Then with the same rule, you're gonna measure that the marker is inside the two little arrows right there. If the marking is above the two little arrows, it's not a good installation. Make sure you don't damage the piping when you cut in the insulation. Okay, clean and use a good copper piping. Make sure that everything is correct and just use a clean piping. If any debris or something, just clean it. Use the round type. Don't use the oval because it's not going to fit in the joint. in the DGT. If for some reason you didn't do a good installation there, you cannot reuse the DGT. You have to use a new one. All right, so going to the software, the new update of the software is gonna give you this option right here, this little square, where if you check it, it's gonna allow you to select the header packs and the DGTs. If you go to preferences and you go to the tab that says piping, you can put the dimensions and the diameters that are available in your country, and it gives you a safety factor. That safety factor, what it is that if you select 5 joints, of the software select 5 joints for you, you can have a safety factor of 1, and in the report it's going to give you a quantity of 5. If you do 1.5, it's going to give you a quantity of 8, and if it gives you, you put a safety factor of 2, it's going to give you 10. So in this way you're going to have a little more just in case you made a mistake and want to reuse one. Right here where you select the condenser, you're going to have the option to select header pack. If you click on this little arrow, you bring it down, you select header pack, and just click back on this blue icon right here, being on top of the condenser, and it's going to start adding the rev nets, adding the header packs, I'm sorry. The report is going to show you this diagram where you can see the header pack right here, right? I have one open right here that I'm not using, so you can, the software allows you to select it, or you can select it with 2 ports open. The only two that you cannot connect are the size, the FS&Q, the ducted, the 2 highest one, the 6 and 8 tons, the 200 and the 250, that you cannot connect into the header pack because they use a bigger piping. If you right click on one of these lines, it's gonna open this screen where you can click on connection details, and it will tell you what DGT are you using on that line. Okay, and the last thing is the report, the material list. It's going to show you the header pack and it's going to show you the DGTs right here, and these quantities is based on the safety factor that you put on. Remember, if you put 1, it's going to give you a quantity multiplied by 1. If you put 2, it's going to multiply by 2. Okay, now we also have the blocks, the cut joints that you can include into your drawings, right? And at this point, I want to talk about some references in the Caribbean, Latin America, and Asia. We have invited one of our DNAs, elite DNAs, Jesus Spinetti from Architect, that was the pioneer on trying this new technology in a project that he has in the Caribbean. Jesus, please.
Gracias, Andrés, por tu introducción. Efectivamente, estamos desarrollando, próximo a inaugurar ahora en abril 22, el Hotel St. Regis Bermuda and Residence. Este es un hotel de 5 estrellas de alta espectro, de alta gama, de unos 240.000 pies cuadrados distribuidos en 3 edificios, de 5 pisos cada edificio. Tenemos unas 122 habitaciones y adicionalmente a eso el proyecto contempla 6 edificios residenciales o de condominio de 15 apartamentos cada uno, en un proyecto adicional de unos 290.000 pies cuadrados. En este caso, la solución de Headerpack, que es a la que nos estamos refiriendo, fue desarrollada para resolver una problemática que se nos presentaba en las residencias que vamos a ver. En la residencia, la solución que planteamos fue utilizar 16 unidades exteriores de VRV, las cuales estarían relacionadas o conectadas en el sistema, con sistemas de ductos para un total de 60 unidades interiores. Un sistema de control bajo el iTouch Manager con un SVM para hacer la proyección hacia el control central del hotel. Si nos fijamos ahora en estos planos, este es el proyecto original. En este proyecto, en la lámina o en la imagen de la izquierda, en los planos de la izquierda, estamos viendo lo que es un apartamento o una sección del apartamento completa con toda la distribución de las tuberías. Y la margen de la derecha, estamos viendo, en la imagen de la derecha, estamos viendo es un zoom del área que nos afecta específicamente en tubería. Esas líneas rojas que estamos viendo es resaltando las tuberías o el par de tuberías de refrigerante con el diseño original que fue utilizando el sistema ResNef convencional de Daikin. Ahora bien, el problema es que el cambio de estructura que se desarrolló en el proyecto llevó a utilizar un sistema de paredes portantes, un sistema canadiense, que modificó por completo la división entre las paredes de los apartamentos o de los ambientes de cada apartamento, y esto conlleva a unos elementos estructurales muy anchos, muy ubicables, que no pueden ser modificados, no podemos tocarlos en absoluto, cortarlos como haríamos en cualquier otro proceso con paredes de drywall. Y si se fijan en la imagen de la izquierda, estamos viendo los elementos estructurales de muy anchos, de hasta 8 pulgadas de espesor, que no nos permiten, y con tramas muy seguidas. Eso no nos permite pasar de un ambiente a otro con las tuberías. Si se fijan la imagen de la derecha, ese elemento que estamos viendo ahí, metálico, es justamente el chaff o el tramo del ducto por donde entrarían las tuberías al ambiente en cada piso, y solamente nos queda el pequeño tramo marrón que sería la lámina de drywall que nos permite el paso a los ambientes. Eso llevó a la necesidad de generar una solución, y esa solución se planteó con Headerpack. El Headerpack, vemos en la imagen de la izquierda el proyecto modificado, donde acá en el tramo central, si lo vemos en la imagen de la derecha, está igualmente ampliado o con un zoom. Esa imagen acá tenemos el Headerpack y una distribución de tuberías. Si bien es cierto que es un poco más de cantidad de tuberías que el proyecto con ResNef, no es menos cierto que los diámetros de las tuberías son bastante inferiores. Estaríamos hablando en las tuberías de gas en este caso. Si nos fijamos en la foto de la izquierda, estamos viendo el Headerpack instalado con las 4 líneas de gas y las 4 líneas de líquido, ¿ok? Perfectamente alineados y conectados. Ya para este momento inclusive estaban presurizados, y las otras líneas sin uso se quedan en su condición estándar de cómo llega. Esto nos permite llevar hasta las unidades interiores las líneas de tubería en una forma más sencilla y más cómoda. En la imagen de la derecha estamos viendo uno de los ingenieros instaladores precisamente haciendo la instalación del Headerpack. Debo acotarle en este punto que debemos tener sumo cuidado con el momento de torquear las conexiones. Los espacios entre una línea y la otra son bastante pequeños, y en esa dimensión es un poco complicado o un poco delicado hacer el torqueo de la pieza, ¿no? Para evitar daños en las piezas. A nivel de costo, es algo muy significativo. En esta lámina estamos viendo los 15 sistemas que fueron desarrollados con Headerpack. En la parte superior es una unidad de RXYQ 96 con 4 unidades interiores y un Headerpack para 4 unidades, en este caso 6, y quedan las otras 2 sin uso. Y en la parte inferior estamos viendo las modelos 72 con 3 unidades interiores. Si se fijan en la primera línea, estamos hablando de horas hombres de instalación. Recuérdense que acá, para este momento acabamos de instalar 37 unidades exteriores, outdoor unit, en el hotel, y ya teníamos parametrizados los tiempos de ejecución más o menos en horas hombres por cada tipo de unidad que estábamos instalando. Y eso nos permitió hacer un control más exacto en esta parte. Entonces, en una unidad de 4 unidades interiores con una RXYQ 96 vía ResNef o utilizando los ResNef, hubiésemos utilizado 80 horas hombre. En la utilización del Headerpack usamos 50 horas hombre, ¿ok? Siempre estas horas hombre basadas en un instalador con un ayudante, ¿ok? Un instalador certificado. Si lo transferimos a dólares, que sería donde lo estaríamos viendo en términos monetarios, el costo para el caso de Bermuda, con una hora hombre bastante costosa, ¿ok? Estaríamos hablando de $3.600 por cada sistema de esto. y bajando a 50 horas hombre estaríamos hablando de $1,750. Esto realmente es el grueso del ahorro. Si se fijan, el ahorro total es de unos $1,952, que representa el 51% de esta instalación. Y en el caso de las unidades interiores, hubiésemos tardado 60 horas hombre y lo hicimos en 40 horas hombre, con un ahorro de unos $1,300. El otro ahorro que se ve reflejado acá son las diferencias de costo en cuanto a la tubería. O sea, al no tener que usar el bracing, el nitrogenado para hacer la soldadura, sencillamente estamos ahorrando esos materiales. Y esos materiales fueron cuantificados, que si bien es cierto, es poco el valor con respecto a la hora hombre, no es menos cierto que es considerable, porque este ahorro pudiera pagar el costo del mismo Headerpack, ¿no? Ahora bien, si esto lo llevamos a el proyecto de un edificio, estamos hablando que en la sumatoria de esto nos da unos $26,000. Y no nos olvidemos que hablé de 6 edificios. Cuando estamos hablando de 6 edificios, estaríamos hablando de unos $150,000 de ahorro en este proyecto, ¿ok? Que es, al fin y al cabo, es dinero que se está ahorrando nuestro cliente final, dándoles nosotros los beneficios de esta aplicación de estos equipos, de este Headerpack, que es lo que nos permite esto, la ayuda. Recuérdense que el no utilizar la soldadura nos permite hacer un trabajo mucho más rápido. El no utilizar tuberías de 20 pies, sino tuberías de 50 pies, nos está ahorrando el trabajo y es mucho más maniobrable la tubería flexible, que en este caso la tubería rígida, aumentando la complicación que nos daba el desarrollo a través de todas esas paredes estructurales que ninguna estaban alineadas y nos permitiesen mantener una línea bastante pareja en esto. Sí les recomiendo 2 cosas en proyectos para el caso del Caribe, ¿no? La primera es el utilizar este sello. Es un sello para refrigeración y gas que nos permite evitar el asiento de la tubería en el Headerpack. Nos ayuda. Al colocar el sello nos dimos la tarea de poder cuantificar al momento de presurizar que no se generaban pérdidas mucho más rápido. Cuando no colocamos el sello, en algunas de las unidades nos quedaban fugas y esas fugas nos costaba bastante trabajo conseguirlo, porque sobre todo la fuga se genera al momento de sobrepasar las 500 psi de presión en nitrógeno y empieza a bajar muy despacio y entonces es bastante complicado conseguirlo y te va a llevar bastante tiempo de trabajo. Entonces es preferible definitivamente usar el sello, es un costo muy bajo, pero nos da mucho beneficio. Y la otra recomendación que debo hacerles es manejar los sistemas de recubrimiento anticorrosivos, conocidos como coating en los Estados Unidos, ¿okay? En los serpentines y en los gabinetes de los equipos. Esto, abrasión producto del ambiente salino y las arenas a nivel de las playas, generan daños en los equipos que le reducen la vida útil del equipo. Con esto podemos lograr garantías hasta de 5 años para los equipos en el Caribe. Andrés, muchísimas gracias por permitirme compartir esta experiencia con ustedes y les recomiendo altamente la utilización de los Headerpack.
All right, let's talk about another projects that we have in the world. This is an interesting project in India where it's a 22-floor building and they install 60 outdoor units, right? They use the Headerpacks and the DGTs. As you can see on this floor plan on the left, every red circle is a welding spot, right? So they have a total of 64 bracing points. When they switch to Headerpack, they avoid all of those welding points. And from the Headerpack, they just connect it with flexible piping. As you can see, they save a lot of time, and they didn't need any special talent to do those weldings, right? Now, they didn't have to bring any fire into the place, so that's why it was a safer application. They didn't have to bring these larger tanks for doing the bracing or nitrogen to weld with nitrogen, so there is savings everywhere. Now, this is just an example, a comparative, where they used to, let me go back here again. Labor per day, they use 25 people. This is without the Headerpack, and this is here with the Headerpack. So they use 25 labor person per day, and they reduce it to 9. So they start saving 64% just on labor. And then we got materials, and the reduction was 23%, right? Now, if you multiply that by 60 outdoor units, that brings you to $7,920, close to $8,000 that this person saved on just on the installation. And remember that 60% of the installation, 60% in a project comes from the installation, and 40% comes from the equipment. So we are saving on that 60%. So this person saved close to $8,000. Now here's another project in Tokyo where they save from 8 people to 4 people. That's a 50% saving. And in labor and materials, they save 35% per system. So there was a lot of savings on that too. Here's another project, a different specification. This is a 72 floor, very tall building, and the problem here was to get everybody in the one elevator that they have to bring them upstairs to do the job. Imagine you having to carry those big tanks to do the brazing or to bring the nitrogen to do the welding. So that's gonna be difficult, right? So they switched to the Headerpacks and the DGTs, and they were able to do a cleaner and faster installation. Another projects, the Tokyo Station, the Tokyo Olympic Stadium, the Umeda building. This is the Daikin headquarters in Japan. Every new product we install it here, and then it's launched to the world. This is a very interesting project because this is the tallest building in Latin America, probably the second one now. We did it with the DGT. Remember that we have the lab, the workshop, PPM Workshop in Chile, so they have more projects in this market, right? So we did this Costanera Center, and that was like 7,000 tons of refrigeration in there. We also have the Novotel, it's another big project in Chile. The Cinemas Complex also used DGTs, another office building, 67 outdoor units. We also were awarded a VRV home project in Nagpur, in which we also used the Headerpack. Now, Daikin is offering a warranty on the Headerpack and the DGTs, a 1-year warranty on this equipment. And what is it going to be included? If it finds a leak in the Headerpack or a leak with the DGTs, we're gonna pay for the repair costs, we're gonna pay for the parts, we're gonna pay for the expenses of sending an engineer or an expert to review what's going on. So Daikin is very focused to promote this equipment, so that's why it's offering this additional warranty, right? So this is the conclusion, and for my point of view is that this is the future of the air condition, the future of the installation of the VRV, right? Because we know that you are busy with many projects, handling many projects at a time, and sometimes you have to subcontract other people, and sometimes those other people may not have the training to do this type of VRV installation. So we are bringing something new that is going to avoid any future problems, right? It's easy to install. As you can see, there's no welding involved. It's just a flare connection and a joint connection, and it's just easy to install. It's faster to install, more economical. You save space, so it's win-win-win everywhere. Just by using this solution, you're going to be saving between 30 to 40%. With that, I conclude my presentation. If you have any questions, feel free to ask us.